Given the differential equation x dy dx equals square root of 4 minus y squared, find the general solution given that y equals 0 and x equals 1. Find the value of y. Alright. So, first here I want to change this to the following. See that 4? I'm going to change that to 2 squared. Can anybody tell me why I'm changing that to a 2 squared? Because if you look up your integration tables, when you integrate that, that will be, is a sine inverse. It'll be sine inverse x over a. Okay? So here's what we're going to do. I'm going to bring the dx and dx over the other side. So I'm going to get 1 over x dx on this side. And then on the other side, it should be 1 over 2 squared minus y squared dy. We all on board so far? Okay, what are the limits? 0 and 1 and x and y. Okay, what do we get when we integrate this? Sine inverse y over 2, yeah, from y and 0. And what about this one here? Ln x from what, guys? X and 1. I'm taking a shortcut here, because what does it say my upper limit can be? You see that one there? That looks weird, but what could we do with it? The cube root of e to the power of pi over 2. Is that not the same thing as e to the power of pi over 2 multiplied by a third? Which is actually the same thing as e to the power of pi over 6. That'd be much quicker, wouldn't it? So what am I going to change this limit to? What can I change the upper limit to, guys? Exactly. Left of that other nonsense. I don't want to have to even think about it. Oh, sorry. It says general solution, doesn't it? If it doesn't say general solution, that's perfect. But if it does say general solution, then you have to keep it as an x. So that option would be there if it didn't say general solution. All right. So we do actually have to keep it the way we had it earlier. Okay. So what are we on for now? Sine inverse y over 2. Sine inverse 0, which is 0. So I don't need to worry about that. There is a sine inverse 0, but we don't actually need it. So we just get rid of it. Okay. And then on the other side, ln x minus ln 1, and we already know about ln 1, don't we? Now, what happens when we bring sine over the other side? Sine ln x. What about the 2? Sling it up. What do we get here, guys? 2 sine ln x, which is the correct answer. And what does it want me to sub in for x? E to the power of pi over 2. So ln e to the power of pi over 6. Anybody know the answer for that? Pi over 6 ln e, which is just pi over 6. So 2 sine pi over 6. 2 times a half, which is 1. That wasn't bad, actually. That 21 was easy. That was, so what we can do here is we can say it's 1 over y to y equals x sine x dx. And you have your limits 1, 0, x, y. Now, your only problem is this part here. You're going to have to use the, it u dv or v du? I was getting confused. Then you have to use in late. So is there any indices? No. Any logs? No. Any algebra? Yeah. So your u value is x. And that means your v value is sin x dx. All right, I'll let you get a head start on me on this one. Okay. I think we can all box off that this side is, we can all box off the left side is ln y from y to 1, which is quite simply ln y. So we don't need to worry about that side anymore. Now we're very much worrying about the, we're very much stuck on the red box here. That's what we're trying to figure out at this point in time. Okay, so did everybody say that u was x? Yeah. And then what I'm going to do is I'm going to integrate the v parts. When I integrate the v, what do I get? V, because it's integral of 1 to v, which is v. Well, I'm going to integrate sin x. What do you get? Minus cos x. And then we're going to use our formula. uv minus v du. Now, we gotta differentiate this part as well. And what happens when we differentiate that? We get du dx equals, which implies that du equals dx. Okay, so let's run through this now. So it's uv, what's uv again? Minus x cos x, yeah. Minus the integral, what's v? V is minus cos x dx. See those two minuses? What am I going to do with the two of them? Take one out and turn it into a plus, yeah? And finally, what happens when we integrate a cos x? It turns to a? Right. We got that. Now, got to put those limits on it now, don't I? What were the two limits we were looking at earlier? X and 0, wasn't it? I think lucky enough for us, the 0 one's just going to wipe it all out. Because the 0 will wipe that out, and it'll be sin 0 at the same time, so the 0 one counts. It'll just be the x value we just had to sub in, which is already done. So in a way, I could just do this. Okay. And our answer will be what then? Yeah. So kick up the e, and be e to the power of x cos x plus. Yeah, that's your answer. Okay, deep breath, part 1 done. Take your solution and verify that y equals 1 when x equals 0. No hassle. All we have to do is put 1 here, and then we do e to the power of 0, isn't it? So that's going to be 0 plus 0, and 1 equals e to the power of 0. Therefore, e to the power of 0 is 1. I don't know what they're thinking in this question, but the solutions are insane. Okay, done. Yeah. All right, done.